The Cafferty Group, Technical Service Advisors, with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Superheat and Subcooling. Let's start with superheat. The balancing act. With the proper refrigerant charge in the system, maintaining the proper balance of refrigerant in each coil is critical for proper performance. Maintaining the proper balance of refrigerant is accomplished by a properly charged and functioning refrigeration system. Proper balance can be ascertained by measuring the operating evaporator superheat and condenser subcooling. Superheat is defined as the heat added to a refrigerant past the point of vaporization. A vapor is said to be superheated when the temperature is greater than its saturation temperature at the same pressure. In a refrigeration system, the correct amount of superheat is necessary to assure that no liquid refrigerant enters the compressor. Too much superheat causes motors to overheat and burn out. Not enough superheat causes compressor slugging and failure. Here is the layout of a basic refrigeration cycle in cooling mode. Superheat is the difference between the saturated evaporator temperature and the temperature of the vapor leaving the evaporator on the suction line. In other words, the amount of heat removed from the indoor air by being absorbed by the refrigerant. Checking superheat. Tools for accurately measuring superheat. Connect a gauge manifold set to the suction line service port. Convert the saturated evaporating pressure to its equivalent saturated temperature by using a pressure temperature chart. Install a pipe clamp or other type temperature sensor with adequate contact on the suction line per the installation instructions. Check superheat per equipment manufacturer's installation instructions. To measure superheat, measure the suction line pressure. For accuracy, you may have to account for a long piping run pressure drop. Convert pressure to saturation temperature, either from the chart on your gauges or a PT chart. Measure suction line temperature at the outlet of the evaporator and at the inlet of the outdoor unit. This shows if excessive superheat is gained through suction line length. Subcooling. Subcooling is the heat removed from the refrigerant after it has been condensed into a liquid. Subcooling is the temperature difference between the saturated refrigerant temperature in the condenser and the temperature of the liquid refrigerant leaving the condenser in the liquid line. What's the purpose of subcooling? It ensures that 100% of the liquid, with no flash gas, is being fed to the metering device at all times. Checking subcooling. Tools for accurately measuring subcooling. Connect a gauge manifold set to the liquid line service port on the outdoor unit. Convert the saturated condensing pressure to its equivalent saturated temperature by using a pressure temperature chart or the chart on your gauges. Install a pipe clamp or other type temperature sensor with adequate contact on the liquid line per the installation instructions. Check the subcooling per the equipment manufacturer's installation instructions. When checking subcooling, Allow the unit to operate long enough to ensure a stable operation. Attach an accurate temperature sensor to the liquid line near the liquid line service port and ensure that it makes adequate contact and is insulated for the best possible reading. Record the temperature reading. The temperature read with this sensor should be lower than the converted saturated condensing temperature. Connect a manifold gauge set to the liquid service valve and record the pressure. Discharge pressure may be used, but the condenser coil pressure drop must be subtracted. Using a pressure temperature chart, find the saturated temperature of the measured or calculated liquid pressure. Subtract the liquid line temperature from the saturated temperature. The difference is the amount of subcooling. Determining operating subcooling. Measure the liquid line pressure. Convert that pressure to a saturated temperature. Measure the liquid line temperature. Subtract the measured temperature from the saturation temperature. The difference is the operating subcooling. R410A pressure temperature chart. What information can be found on a pressure temperature chart? By looking at the liquid and vapor pressure, you can read the equivalent temperature. Thank you for joining us for this training on superheat and subcooling. If you have any questions or need more information, please contact the Cafferty Group Technical Service Advisors at one of these 12 locations.